Welcome back to AI Weekly News by Cyber Intel Systems. I'm glad you're with us. I'm your host, Leo Smith. Today's story is about TCS survey maps, physical AI ambition, and factory readiness. TCS surveyed chief executives and vice presidents at 300 manufacturing companies across North America and Europe during March and April 2026. Respondents came from automotive, electronics and high technology, industrial equipment, process industries, and aerospace and defense. The report therefore captures senior management views across several industrial sectors rather than a census of all manufacturers. Physical AI brings together robotics, computer vision, sensors, edge computing, and models that help machines interpret changing conditions. Possible applications include inspecting products, moving materials, predicting equipment problems, and assisting people with repetitive or hazardous work. Each use case has different data, latency, safety, and reliability requirements. The report builds on a TCS and Google Cloud initiative launched in March. Their Physical AI Gemini Experience Center in Troy, Michigan, is intended to let manufacturers explore and test robotics, inspection, maintenance, and operational. A test center can lower experimentation barriers, but it is not evidence that those systems have reached routine production. Warehouses received the highest expected impact in the survey, with 77% anticipating significant or transformational change. Assembly and manufacturing operations followed at 75%, and logistics and material movement at 72%. Workforce augmentation was another major theme. 42% of respondents expected significant augmentation through physical ATT and support in complex, hazardous, or repetitive settings. The survey does not establish how many jobs will change, which skills will be needed, or whether workers share executives' expectations. The readiness gaps are concrete. TCs identified legacy system, integration, data infrastructure, and workforce skills as leading barriers to scale. A robot demonstration can work with created inputs, while a production deployment must connect to old equipment. Inconsistent operational data, maintenance practices, commerce, failure. The contrast between investment plans and deployment maturity is the real market signal. Vendors can expect demand for integration, simulation, sensors, edge computing, governance, and training, not only for robots or foundation models. Manufacturers may spend as much effort preparing data and weakwebs as selecting an AI model. Let's pause here for a short break. We'll be right back after this bumper. Welcome back. If you find this useful, follow and subscribe to AI Weekly News. Now, let's continue the news. Warehouses may move earlier because tasks such as routing, inventory movement, and visual inspection can be bounded within controlled spaces. Assembly lines can be less forgiving when timing tolerances and worker proximity create safety-critical dependencies. The survey's ranking should guide questions, not be treated as a universal deployment order. Long value realization. Timelines also change investment decisions. A physical system cannot be updated as casually as a web application when it controls machinery or interacts with people. Buyers need to account for installation, validation, operator training, maintenance, fallback procedures, and the useful life of both the machine and its software. Governance appears less mature than spending intent. 44% of respondents reported unclear or absent formal accountability. Those gaps become more serious as systems move from recommendations to actions in shared physical spaces. A useful accountability plan should identify who approves a model, who validates a change revoke, who can stop a machine, and who investigates an incident. It should also preserve versions of models, sensor configurations, prompts, and operating rules so a result can be reconstructed. Without that evidence, organizations may struggle to learn from near misses or assign corrective action. Adoption should be measured at the task level. Useful evidence includes defect detection, accuracy, false stops, throughput, unplanned downtime, worker interventions, safety incidents, and performance after lighting. A successful pilot is one that keeps working under production variation, not one that performs once in a controlled demonstration. The TCS report shows a manufacturing sector preparing to invest in machines that combine perception, reasoning, and action. Most respondents are still before full deployment, and many lack clear accountability or regulatory readiness. The next evidence to watch is not another investment, intent percentage. It is the number of systems that graduate from experiments into sustained production with published reliability, worker safety, and governance. Physical IE will become meaningful at scale when factories can show not only that machines act intelligently, but that people can control, audit, and recover from those actions. Thank you for listening to AI Weekly News by Cyber Intel Systems. Subscribe and join us next week for the latest AI stories.